Of course, strings can be compared, and there is a set of operations that are available for comparison. One of the comparison functions is named compare, and it returns 0 if all characters are equal. It returns a negative result if the first character doesn't match, compares to less in the object than in the comparing string. So it's called lexicographical comparison. And otherwise it returns a positive result. For instance, here we can compare one string with another string. So we just initialize the first string with hello world and another one with Fred. So because the first character here is H and the second character here is F, then H appears to be later in alphabetical order in the character encoding table, just like in regular alphabet. So H is greater than F, and therefore result returned here will be positive result. Now, if we're extracting from the 6th position of this string, okay, so this would be 0, 1, 2, 3, 4, 5, 6. So this would be from this character right here to a known position, which is basically go through the entire length, which would take this, right? So this specifies that we want to use a substring of string 1, and it's just this. And we'd like to compare it with the zone, okay, world and zone. Okay, so in this case, W is less than Z, right? So the first character of of world is less than Z, and the result of compare is negative. In addition to this very formal comparison using compare function, we also have a set of overloaded operators for strings that allow us to use comparisons for equality, inequality, less than, greater than, less or equal, and greater or equal. And you can see that, of course, you can rely on the results of the compare function, which was covered in the previous slide, to implement the true or false outcome of these comparisons. Okay, so for example, compare function returns 0 in case if the content of both strings is equal. So it will return 0 right here. So that's the implementation. Another operator which is overloaded for strings is plus operator, and it concatenates two strings. Basically, you can say string 1 plus string 2, and it will concatenate them to create new string which contains the content from both of these strings that were specified with the plus operator. All of the examples of overloaded operators we will use in our next section when we're formally talking about the rules for overloading operators in C++. But here is just an idea that there's lots of flexibility in terms of using these operators to compare strings in alphabetical or, strictly speaking, lexicographical order of characters that they contain. So in summary, string is extremely popular container in C++. It's easy to use, it's very intuitive. You'll find plenty of all sorts of very useful functions which basically allow you to construct strings, use assignment, generate all sorts of iterators to use those iterators with, for example, C++ standard library algorithms. You can check the capacity, like the size and length, and you can even reserve characters in your strings check whether it's empty. Element access we discussed already. There's a subscript operator, and which is unchecked memory access or character access, and this is checked. And there's also back and front, just like we had the examples in vector container. Modifiers allow us to append and assign and insert, erase, and replace. You probably want to look at the examples specified by c++.com reference for the string. And string operations include these the family of find functions that allows you to locate information inside the string. You can also extract substrings. So there's plenty of tutorials online that cover a lot of this, and behind each link to these member functions you will find examples. And then these are the operators that we discussed there. Just be a little bit careful with this. The idea is to use a pointer to the content in the C style code, but never retain that pointer, because it's very volatile pointer and maybe unsafe to continue using it. So it's better call this function again rather than call it once and retain pointer to a C style string. Just a lot of functions here have default parameters, and just check the signatures of the functions that use default parameters, so you don't have to specify all of the parameters with every function call. Here, in summary, it may appear to you that square brackets, the subscript operator, gives you ultimate control over the content of the string. So you may just create your own loop and start using index inside these square brackets to access individual characters and do your custom searches and custom finds, comparing every character to whatever you're searching for. However, remember, there's whole family of functions that are already written, and it's very likely that if you're working on developing your own version of find, it's very high probability that you could be using one of these functions already. In our next demonstration, I'll actually use a few of these string operations in the actual example.